And, the results from that program are going to change the way we look at the Kalahari Copper Belt and target in general.
Their focus has been on spending money in the ground. Too often we see other explorers spending it elsewhere.
Because this project has potentially, 200 million tons of ore.
And we now know that we can produce a copper cathode from the lab itself, which allows the company to have the confidence to move ahead to do this on site itself.
At the moment, all our projects are at a really interesting stage. We have active drill rigs running on 2 of the projects. Those drill rigs are currently drilling on our Angami project. We're looking at the Cosmos target, where we've had some really good results recently, which have been released to the market. That drill program is going to be extended well into next year now, based on these results, which has been really encouraging. And then we also have a drill rig running 24/7 on our Okavango copper project. Again, with that project and its strategic location, any hole will completely change the movie for the company.
So we have a very strong board with a lot of experience, probably over about 100 years of combined experience on the board itself. We also have a lot of authority bias, as you call it, from all the experts that we have working with us as a company, as consultants. So we're using Metz Engineering out of Perth. We are using WSP as hydrologists. And we're using an environmental group called Loki in Botswana to do all the environmental permitting. And we've also got a strong drilling company in Mitchell's Drilling as well that's doing a lot of our exploration for us. So in regards to that, there's a very thought out process that goes through this. From a top down, we actually tick every single box in regards to de-risking a project before we move forward. And at the moment, we haven't seen any fatal flaws in this project.
We first started working for Cobre in 2021. And from day one, we saw a team that was absolutely focused on putting their capital into the ground. One of the main reasons why Mitchell Drilling has been prepared to take equity is we see a real promise in the Kalahari Copper Belt. We like what the guys are doing. Their focus has been on spending money in the ground. Too often we see other explorers spending it elsewhere. And in the exploration game, it's all about money spent finding the resource.
And I myself have done a lot of work on copper. I was involved in Bougainville Copper, which was a huge project in Papua New Guinea. I also worked on the feasibility study with Fluor for Olympic Dam, which is a world-class project, and I've been there many, many times. In fact, I was there last week. But essentially, why is In-Situ copper recovery attractive? It's a low-cost operation. There's no waste dump, there's no tailings dam, so there's minimal disturbance. It's also scalable, and because this project as potentially 200 million tons of ore, you can keep putting more injection wells, more recovery wells, so you can start off small and then you can scale up.
In the Kalahari Copper Belt, Cobre applies In-Situ copper recovery. This clean and efficient solution-based method starts with leaching solution pumped into the ore body through injection wells. Underground, it reacts with the copper-bearing rock, dissolving copper and silver into the fluid. This mobilizes the metals efficiently while leaving the surrounding rock intact. Pregnant leach flows through recovery wells to the surface, where it is collected in the pregnant leach pond. Here, the fluid is temporarily stored and conditioned. The solution from the pregnant leach pond enters the solvent extraction plant. Here, copper ions are transferred from the aqueous solution into an organic solvent, concentrating the copper and removing impurities, producing a high-purity electrolyte ready for electroning. The remaining solution from solvent extraction flows back to the pond for reuse, while the enriched electrolyte moves to the electroning plant. In the electrowinning plant, electricity moves copper ions onto cathode plates, forming pure copper sheets, which are then collected and shipped as a high-quality product. Lean electrolyte flows back into the raffinate pond. The lean electrolyte is also used to help restore groundwater pH. After the copper has been extracted, the ground is gradually restored, with clean, treated water added to stabilize the soil. All wells are then carefully removed and sealed. Within a few months, there are no visible signs of copper or silver extraction, appearing fully natural and undisturbed.
So Cobre itself has identified a very large exploration target in excess of 300 million tons of copper and also around 32 million ounces of silver. This is of significant scale. In regards to that, there is another company called Taseko Mines, which runs the Florence Copper Project. This project itself is about to go into full production. So it shows that this method is working in the in-situ copper recovery market. On top of that, Cobre itself is in a position now that we're moving ahead from our development from early stage exploration through to building a demonstration plant on site. This will give a lot more confidence to Cobre as a company once we start actually producing copper cathode on the site itself. And this will lead us to the next stage, which is our starter plant operation, which starts producing quite a lot of scale of copper from that. And then we move to the full production stage of this, where the company itself is targeting circa around 30,000 tons of copper cathode per annum. If the company is able to achieve that, then we'll be a significant player in the copper cathode market.
We started work here more than 7 years ago. The Kalahari Copper Belt at the time was very much an exploration play back then. And this really allowed us to put together a massive land package. Now we've got more than 5,500 square kilometers under license in Botswana. That makes us the second largest landholder in the Botswana Kalahari Copper Belt. Over the course of 7 years, we've been able to prove that every single one of these projects has real district scale opportunity for new copper discoveries. We've also been able to put an MRE together on our Ngami Copper project. But you're looking at a massive land holding, and to make success now, you need to be drilling, and you need to be drilling on all these projects. So we basically adopted a three-prong strategy to how we were going to approach this land package. And the way we did this was firstly to look on our two base margin projects, where we saw real opportunity for making major sort of tier one size discoveries. And this was looking for these big buried fold hinge zones that may not have been discovered, right on the base margins where you get the big fluid flow and the major systems developing.
So the key upcoming milestones for Cobre as a company ranges from the partnership that we have with BHP, also the recent investment that has occurred by Sina Mines, and also our development project that we're working on, which is 100% owned by Cobre as a company. In regards to those milestones, there's a huge amount of data that's going to come out in 2026. We're expecting to see results from BHP, we're expecting to see results from Sina Mines, and we're expecting to have our demonstration plant in operation in 2026.
As part of the trial, we installed two production wells. They were spaced 80 metres apart, and both of them targeted the copper mineralisation. In and around those wells, we installed some monitoring wells to help us track the movement of fluid. During the trial, we injected into one well and pumped from the other well to see how fluids could move through the ore body. The test showed that copper mineralisation has really good permeability, which means that fluids can flow easily through the copper mineralisation. The results showed that the copper mineralisation is higher in permeability, which promotes higher injection rates and the lateral spreading of the fluid throughout the copper zone, which will ultimately improve copper recovery.
What excites me is that for uranium, in situ leaching is well established. It's proven technology in Kazakhstan and South Australia and elsewhere around the world. But for copper, it's not the case. The reason is, I guess, there hasn't been the unique ore bodies that are amenable to in situ leaching. And that's what we've got here in Botswana. Um, so yes, I've worked on some very large copper projects. Bougainville Copper was a Rio Tinto project, had a very high technical standard. Um, Obviously, in terms of development, there are challenges, and so far, all the challenges like hydrology and metallurgical recovery, we've actually been quite pleasantly surprised with the results.
ICR really relies on a very unique geological conditions. So it's not something that's applicable to most deposits. You require that your ore body is leachable. So in our case, we have chalcocite as our primary ore mineral, and that can leach and float, which is quite unusual. It's fine grained, it's fracture hosted, it's cleavage hosted, so you can actually access it with an injected leaching agent. Um, it's below the water table, which is also unusual. You'd normally have your leachable ore being above the water table. So this is quite unique. And then we have this fracture-hosted mineralization that literally extends for tens of kilometers on both limbs of this anticline. So we've got an extensive ore body that can be beneficiated. The key for making in situ copper recovery work is where it works, and we seem to be in the Goldilocks zone for the correct geology. Where it works, you would have opportunity to do an OPEX, CAPEX right at the bottom of the global cost curve, on top of using an environmentally friendly method. You have no surface tailings, you have limited surface infrastructure, and you literally rehabilitate as you progress along your well field. So it really is environmentally friendly, cost-effective way of extracting copper from the deposit.
So the simple way I see this is that if you have a project that sits on the bottom of the global cost curve, you can weather any storm. And so what that means is when supply is tight or demand is strong or vice versa, you can always survive an operation whilst you sit on the bottom of the global cost curve. This is also extremely important for metal traders and off-takers alike to have projects that sit on the bottom of the cost curve. So if there's any turmoil in the future, it allows the project to survive long term and to weather that storm again, and then to reap rewards once the market turns.
An in-situ copper recovery pilot trial is planned. It will utilize a series of injection wells and recovery wells. So in the first test, we used one injection well and one recovery well. This test will upscale that to multiple injection wells. The regulators have approved the proposed scope of work for an environmental impact assessment for that pilot trial. So now the company has a clear roadmap to the permitting of the pilot plant and the subsequent development.
So from a geopolitical perspective, Botswana as a country is regarded number one in Africa from a mining-friendly jurisdiction perspective. It's regarded in the top 10 of mining-friendly jurisdictions globally. So from a geopolitical perspective, the copper supply that is coming out of Botswana itself is of extreme importance. On top of that, the US Geological Survey rated this belt in Botswana, being the Kalahari Copper Belt, as the #1 belt to explore for new sedimentary hosted copper deposits.
So the Kalahari Copper Belt has really morphed from an exploration play into a producing mining district over the last few years. You've seen both NMG and Sandfire in production now. But despite its status as a producing copper district, it's incredibly unexplored and relatively immature as an exploration play. And this is mainly due to the fact that the entire belt is covered in sand cover. We see this as both hindrance and an opportunity. It's the reason it's immature, and it's the reason you haven't seen more discoveries come up the belt. They're there. The trick is to find them.
It's been incredibly rewarding drilling deep in the Kalahari. It's demanding work. It's difficult. But that's what we do. That's our specialty, is deep hole diamond drilling. We recently drilled the deepest hole in Africa, 2,875 meters. And so we're immensely proud of our team and what we can do. Over the years, we've completed numerous difficult holes, and we're used to working for companies like BHP. We understand their safety requirements, their precision and technically difficult, demanding work that they need. And so we understand this. And obviously we're biased. I honestly believe that we've probably got the best technically deep hole diamond drillers in Africa. And so when we combine that with Adam and the team at Cobre, who run a very targeted and extremely capable operation, it really creates, I feel, a really strong partnership and ability to be able to get the job done.
One of the key aspects of an in-situ copper recovery process is the fact that your final product is actually a copper cathode rather than a concentrate. And this really opens the door to different markets, in addition to saving significantly on your transport costs. You're not transporting a cathode to a smelter in China, for example. You actually have a cathode produced in Botswana. So it's also good for the country in the sense that you're producing a copper cathode in country that can then be addressing both local and international markets.
So there's a lot of communication that we give to shareholders. We keep shareholders up to date regularly in regards to the process that we're going through. We continue to de-risk the project in a systematic way over the years. And now we're moving ahead to that really aggressive part of development, which is really exciting for Cobre and Cobre shareholders. And we'll continue to de-risk that as we move forward.